Hello.
Good evening, everybody.
Good evening. Welcome to the Azure Cloud Native meetup for April 12th. I had to check what actually date it was.
What day is it? What date is it?
Yeah, it's been one of those months, I guess. I have no clue who I am and where I've been. So I'm trying to bet my best to. And as you can see, I'm not in. It's this is not how it looks at home in my place. So. Kind of went back home above the Arctic Circle, fighting polar bears and stuff like that. But I'm trying to keep it going, and hopefully we'll get through the show, right?
Sure.
So welcome to the Azure Cloud Native meetup. We are a Azure specific, a cloud native specific meetup group, which we started. Me, Carl Cook, Richard Hooper, and April Edwards. We started it because obviously there's a lot of great things in Azure when it comes to cloud native things, but often underrepresented. So we want to start like an initiative to kind of get all the cool stuff out there. And obviously we are a little bit of a community, so we have a code of conduct. I see Carl typing, so I'll put it on screen if you want to run through it, Carl.
Sure. So, well, as Robert says, welcome to the group. It's great to have you here. So in today's session, we'll just ask everyone to adhere to the code of conduct so that everybody can have fun and learn and just enjoy being part of the community. So we ask that you be aware of others, be friendly and patient, be welcoming and respectful, be open to all questions and viewpoints, be understanding of any differences, and most of all, be kind and considerate to others. So we just ask that you bear that in mind as you're interacting with the community tonight. Thank you.
So today we have a special type of event. It's not the typical like normal meetup. It's the spotlight session. So Carl, if you just run through what that is.
Sure. So the idea behind the spotlight session was to have a different sort of out of band user group feel, where we have vendors and projects come on and talk to us specifically about what they're doing in the cloud native space in Azure. So that's about highlighting people, companies, and open source projects that are doing awesome things specifically on Azure around cloud native.
Yeah, and today we're really lucky to have Red Hat representing, and none other than Christian Hernandez, which I'm lucky to be working with on a lot of different things in the CNCF. So let me just like pop you in here, Christian. Hey, Christian.
Hey, everyone.
Hey. How's it going?
Going good. Thank you for inviting me here. It's the first one of these I've done. I know, Robert, you've poked a few people around, right? You invited me on. I go, you know what? I actually do have something to present to the Azure community. So yeah, thank you for having me on.
Yeah, it's really great to have you on. Obviously, Red Hat does a lot of things in the cloud native space and a lot of things with open source in general. And I've looked at so OpenShift obviously is a really popular Kubernetes based, let's call it that, platform of like application platform, and there's some great things going on there directly related to Azure. So I'm sure we're going to look at some of that, and obviously there's a little bit of like both Linux and Windows containers, which is like what?
Yeah. Well, it's funny how you know, when you said, well, what can I talk about to an Azure community that will really resonate with everyone, with the Azure community, with the cloud native, and I'm like, you know what? Let's talk about Windows containers and Linux containers living together. And so so today I put together kind of like a quick presentation to kind of, you know, have something for me to talk to. I always like have something to talk to kind of go over some of the concepts right before I actually go into the demo. I'm more of a demo guy. I'm more of a conversationalist, right? So for those of you who are live, feel free to drop any questions in the chat. Feel free to interrupt me. I told both Carl and Robert to interrupt me. This is, although I have a demo, it's just not just, not just me, talking to myself. So if there's questions out there, please let me know.
As soon as we see one, we're gonna try to shout out and stop you if it's relevant to do at the moment. Were you sharing your presentation? I'm gonna try.
Yeah, let me see if I can. It should be up now. And all right, cool.
Yeah, I'll drop us off. Just you feel free to go ahead, and if there's anything you need from us, let us know, and we'll try to break in if we have any questions. So
cool. Yeah.
Right.
No, appreciate it.
Awesome.
All right, we'll bring those guys back in later. So again, my name is Christian Hernandez. What I do at Red Hat, I'm a senior principal technical marketing manager, which I always say is a long title, one of the longest titles. We have a long title here at Red Hat, but a lot of especially Robert, me as a GitOps guy at Red Hat. I'm also the Windows Containers guy at Red Hat. So if you believe that, I have two. Many would think opposite ends of the responsibilities at Red Hat. But what I want to talk about today is OpenShift and Windows Containers on Azure. Right. So we have, when I was invited, it's like, okay, well, it's an Azure user group. I'm like, oh, I have, a really cool subject here. I'm going to go over, not only cloud native, not only OpenShift, not only Azure, but Windows Containers as well. So what I'm going to do is I'm going to power through these slides, right? Because I'm a demo guy, right? I love demos, right? And in knock on wood or touch wood, right? We are to the demo gods. Hopefully they'll be with me today. What I'm going to go over is what is OpenShift, right? As Robert alluded to, it has something to do with Kubernetes, but I'll go into what is OpenShift, so you guys have kind of a foundation of what it is. What are Windows containers, right? And that sounds weird maybe to some of you, but what are Windows containers? Then I'm going to go into a demo, right? I'm going to leave time for discussion, questions, wrap up anything you guys want to have a conversation about. These look like a very short agenda, but there's a lot to cover, right? And so I'm going to dive right in to what is OpenShift, right? So quick background on what OpenShift is. And so I always like to, when I start talking about OpenShift, I like to go to this this Kelsey Hightower quote about Kubernetes, right? And again, there's a source there. You can actually look at it yourself. It says Kubernetes is a platform for building platforms. It's a better place to start, not the end game. And I always say that if you think you're using vanilla Kubernetes, you're not. And the example I always give is that if you are going through the Kubernetes the hard way, right? Kelsey Hightower's Kubernetes the hard way, you never, ever install a CNI. And the first thing people do when they install Kubernetes is install a CNI. So if you're running a CNI, if you're running a networking, congratulations, you're not running vanilla Kubernetes, but it's more than that, right? Again, like Kelsey Hightower is a platform for building platforms. So when you install Kubernetes, you need things like I said before, networking. You need things like authentication, the web UI. There's monitoring, alerting, metrics, storage, and then automation. Developer experience, operation tools. There is a lot that goes into building your Kubernetes platform. And so this is an old picture. This is the CNCF landscape from 2019, 2020. Kind of old, a few years old, but I think it hammers on the point. You install Kubernetes, and then you need to pick all subset of tools, right? You need to go, okay, well, I'm going to install Kubernetes. What kind of runtime am I going to use? Am I going to use service mesh? What kind of monitoring? What kind of security aspects? Like the list goes on and on and on when you install Kubernetes, what you're going to layer on top of it for that platform. And so that's what OpenShift is, essentially. So the OpenShift is an opinionated distribution of Kubernetes. It's a certified distribution of Kubernetes, right? So if you go to the Kubernetes, the certified distributions, right? There's, OpenShift, there's Tanzu, there's there's Rancher, right? There's all these certified distributions of Kubernetes, right? OpenShift's one of them, and OpenShift is just that. It's just a opinionated way to install Kubernetes. So basically, we give you not only Kubernetes, but we also give you all the services on top of that that you not only may want but may need, right? So things like the monitoring stack, right? The networking, ingress, things like Helm installations, platform services, application services, developer services, right? Like all those things that I listed that you need in a Kubernetes environment. OpenShift just gives it to you kind of off the shelf, right? So you go from having Legos to having a complete toy, right? So you're just buying something off the shelf. And OpenShift is using all the, basically kind of curated applications or offerings from the previous slide I was showing you. The landscape, right? I only showed you this for to not talk bad about the landscape, just saying there's a lot of stuff we actually pick from that landscape and deliver that into like a complete package. And that's really only one part of OpenShift, right? And so OpenShift has an opinionated distribution of Kubernetes with handpicked CNCF landscape, services. Let's put it that way. But beyond that, OpenShift has a full stack automation, right? So OpenShift essentially from day zero, you get a fully fledged Kubernetes platform to use in production as soon as you hit enter. So we have an OpenShift installer, right, that connects to your underlying infrastructure. And it'll deploy everything it needs in order for Kubernetes to even get installed, right? So even before Kubernetes even touches anything, things need to be up, right? Networks, internal, external load balancers, DNS, Red Hat CoreOS installation, right? So the operating system installation, getting the networking and all the stuff you kind of have to do manually. The OpenShift installer does that for you. So the automation is another big component of OpenShift, right? So first big component is basically it's just an opinionated install of Kubernetes. Second component, fully automated, and it's done that with the operator lifecycle management. So operators are another big part of OpenShift 4. I think it's out of scope a little bit for what we're talking about, but just I'll touch on it a little bit later. But operators is the underlying automation aspect of OpenShift 4. So OpenShift basically Red Hat's taken the opinion of OpenShift everywhere, OpenShift anywhere, right? And so when I talk about go back a slide about this full stack automation, right? You just run one command and everything comes up. So where can you run that? Right, so then you have essentially all the hyperscalers and the cloud providers, including Alibaba Cloud, including bare metal, including things like OpenStack, IBM Cloud. But I think for the focus of here, I'm going to focus on Azure. Azure is one of those providers where you can have a fully automated installation of OpenShift, right? You just download the OpenShift binary, you provide the OpenShift binary your Azure credentials, and off it goes. Also, right, so this as well, right, so instead of providing the OpenShift installer your credentials, Red Hat and Microsoft have partnered to offer something called ARO, or Azure Red Hat OpenShift, right? So this is basically OpenShift that you can order from the marketplace, right? You give Microsoft your credit card number, and they will you consume it as a service, meaning that it's a managed offering, right? And so it's jointly engineered, operated, and supported by both Microsoft and Red Hat, and an integrated experience with Azure. So so this is kind of I don't really want to install OpenShift myself on Azure, but I still want to reap all the benefits. you can go to the marketplace on Azure and just order ARO, right? And so you get support not only from Red Hat, but also Microsoft jointly engineered and support. And this is the pay-as-you-go model, essentially. So the OpenShift is basically you pay for the infrastructure you're consuming, and whether you're using it or not. If you want more of a pay-as-you-go model, more of a consumption model, ARO is there on Azure as well. I wouldn't be doing my job if I didn't name drop, right? And so, why Red Hat, why Microsoft, right? And so this is Red Hat Summit Boston 2019, back when we actually had in-person events. A lot of the times the people think of Microsoft and Red Hat as almost like enemies. We'll leave that for the OS guys, right? We leave that for maybe the Rail guys. I'm on the cloud team, so where Microsoft and Red Hat kind of joined together as their vision of the cloud, and we have essentially the same customers, right? And I think that goes, I'm kind of alluding to kind of like the next topic I'm going to talk about. Is Windows Container Support for Red Hat OpenShift. That's actually the official name. Colloquially or in internal Red Hat, we just say Windows Containers, and we know what you're talking about. We don't. Now that we kind of talked about OpenShift, about Kubernetes, let's talk about Windows Containers and where that fits in with the OpenShift ecosystem. Right. And so, like, why run Windows containers? And so I was alluding to before how, Red Hat and Microsoft have a lot of the same customers, and we coexist in the same data center. If you're running a data, I don't think anyone's running only Linux, and I don't think anyone's running only Microsoft, right? And so, especially in larger organizations, there's, you're just going to have a heterogeneous environment. And so, Windows still has a presence in server operating systems, right? Windows Server, I think, is, one of the most popular, I think 2019 was probably one of the most popular ones out there. There's a lot of .NET app, and so they're still out there, right? People still using .NET, people still writing .NET. .NET Core came out, right? And so Microsoft's still continuously, supporting that. You would want to run Windows containers, right? And for the most part, we see .NET application being written in Windows containers. Those developers want to embrace microservices, and I think a lot of the times I think of where Linux containers were maybe like 5 years ago. I think that's where the Windows.NET application developers are today, right? Where they kind of starting to think about microservices. And some of the benefits of Windows containers, as we see at Red Hat, and also jointly with Microsoft, is that microservices aspect of it, and the fact that you can use these in the cloud and have accelerate your journey into the cloud, right? And you no longer have to have an anchor of applications. They're sitting, legacy applications that you may want to say, hey, we can't migrate to .NET Core. We need to run this application for a while, and it's maybe anchoring you to to stay in your data center. Well, you can bring those now into the cloud, and I always feel like I'm repeating myself with Windows containers, right? Because Red Hat, so for us Linux guys, for a lot of the Linux guys, me being a Linux guy, we kind of went through this journey already about like containerization and the aspect of it. Those same those same things also apply to Windows containers, right? Now, we kind of just have to paradigm shift. Instead of running a Linux kernel, we're running a Windows kernel. The same idea exists, right? And so where does that all fit, right? And so that really, where does Windows containers and the Windows node fit? They kind of slide in, as you see here, on the bottom right in the same layer as Red Hat Enterprise Linux. And that's really the only difference. You get everything else is the same on the platform, right? You're running Kubernetes, you're running, OpenShift and all its cluster services and its opinionated deployment of Kubernetes and all, and all that it has to offer, and also some of the multi-cluster management system, right, that Red Hat has with, with ACM, with Ansible, and all those things. You get to have really all your application workloads, all your heterogeneous application workloads in one platform. So that's the idea. So why Windows containers? Well, you have one platform to manage not only your Windows containers, but also your Linux containers, all with one pane of glass, all in the cloud, right? All running on Azure. So you're taking advantages of all the services that Azure has to offer inside of OpenShift, right? And so you're using OpenShift, everything it has to offer along with Azure. And then now you're going to bring in your Windows containers with your Windows applications and have that all in one pane of glass. So that's really, really, really attractive. And so what's really cool is that not only do you get the running your Windows containers and running your Linux containers in one platform, you can also get them to interact with each other, right? You can also, it's not just like an isolated thing that you're using. If you're having Windows containers, if you're running .NET applications that are consuming Linux services or vice versa, you can do that also with one platform. And so that's kind of also the idea. Not only you get the north-south traffic, right, having an application consuming the external systems, but also east-west traffic as well. So that you kind of have that all in one platform. And so, how we view things here at Red Hat, right? If you have a .NET Core or modern .NET, whatever you want to call it, you run that on Linux, right? I think that's, a lot of people are doing that. You can run that on Windows Server as well. If you have a .NET legacy .NET or .NET, framework, 4.x, run that on Windows. Keep that on Windows, but use OpenShift to manage it. And that's kind of the idea. Like, where am I running my applications? Hey, if I want to modernize .NET Core, cool. You can deploy that on Linux, on OpenShift, the way it is today. If you have some .NET legacy applications, you can run that on the native operating system. So how does all that happen? Just like with everything, OpenShift has operators, right? So this is all an operator. Anytime someone asks, how does X work on OpenShift, 99.9999% of the time, it's answer is gonna be operator, right? And so that's really the entry point, right? Is seen as a day 2 operation, where once you install the cluster and all the prerequisites, you install the operator and you're ready to go, right? So that's we wanted to make it as easy as possible. Basically make it a catalog inside of OpenShift where it says, hey, I want a Windows node. Let's, let me click ops, right, as we like to call it. You can do that as well inside of OpenShift with the operator framework. And really, it's the operator is essentially a controller, another Kubernetes controller that interacts with the Cloud API, right? In this case, it would be Azure, to create a Windows node and basically bootstrap it for it to be a Kubernetes node, and be a Kubernetes start accepting workloads, right? So it installs the kubelet, installs the CNI, the kube proxy, everything that you think that you would need for Kubernetes, that gets installed on the Windows node, and then it's ready for a workload, right? It's essentially, it's pretty straightforward. It's actually, Windows was able to run these services in the past, but now we've brought that into OpenShift as an actual OpenShift node. So then, you got that full support, not only from Red Hat, but also from Microsoft on all aspects there. So this is not all unicorns and rainbows, right? So, I get this question asked a lot, so I figured I'd throw this slide on here. The number one question is, well, since OpenShift takes care of the Linux updates and RHEL Core OS, does it also take care of my Windows updates? And the answer is no. So, we're a Linux company. We don't know how to patch and update your Windows servers. We'll leave that up to you. So, you would essentially build a new image on Azure and just change that image spec in the containers in the machine set here. So, hey, Robert's back. So do you
Hello.
see?
We had
Yes.
a drop by question. Does OpenShift provide a single pane of glass for clusters across clouds with ability to easily move workloads, or are clusters managed independently?
So OpenShift itself does not do that. What you would need to do for that is Red Hat has another product called Advanced Cluster Manager for Kubernetes, and it's essentially that's the management. It's essentially a service, and you would connect all your clusters to what we call ACM, right? So that's what Advanced Cluster Manager for Kubernetes, what we call ACM. ACM not only takes care of the single pane of glass and management of it, but it also installs the clusters as well. So it's kind of like a full life cycle thing with that.
Right. Thank you.
Yeah, cool. Thank you. So yes, so yeah, I was here. Yeah, so essentially, and there's other methods of management of Windows nodes for patching and upgrading. You can use Ansible. Ansible supports fully Microsoft Windows Server, so that's something else that you can do. But OpenShift itself does not manage, does not take place of your Windows administrator. So you're going to still have to work in tandem. So here now demo time, right? And so so yes, so someone I actually see in the chat here. Carl said multi-cloud, multi-cluster management. That's exactly right with the ACM. So so here. Let's all pray to the demo gods, right? That's why I have my fingers crossed here. I was telling the guys here before we went on air that I literally just finished setting up the demo. So we'll see see how this works here. So I'm going to share my screen.
I'm just here to help you move over to the next screen.
Out here. So I'll share my screen and I'll minimize you so you guys aren't doing. Let me know when you can see my screen.
Got your screen now.
All right. So let's take a look at an overview here, and let me know if there's if I need to make it bigger or if this is fine. So, so this is the OpenShift dashboard, right? OpenShift Container Platform. This is kind of where you get kind of the cluster overview of things that you need, to be aware of, right? So it looks like I have alerts already going here, but I can see the health status of my cluster. I can see the information, right? And you can see here that I'm running this on Azure. And so again, I installed this this cluster on Azure using the OpenShift install method. And so here it'll show me information about unhealthy things. When in a busy cluster, as you would imagine, there's things constantly going up and down. And this is kind of like your pane of glass here. So one thing I do want to note here, you do need to, one, I installed this on Azure, but you need to make sure you install with Windows containers in mind, with Windows nodes in mind, because you need to actually set up the cluster with that ahead of time. So I'm never shy about showing my notes here. So if I can, I'll copy this here. And I'll bring up the terminal here. So this is the embedded terminal for the command line. I decided to. This is actually the first time I'm using this, so so bear with me here. So there we go. So if you see here, there's a few things. I'm using OVN Kubernetes, right, which some of you may be familiar with. And I set up hybrid cluster networking. And really that's it, right? So you say, hey, I'm going to use OVN. And also I'm going to set up a hybrid networking because the Windows nodes have their own CNI versus OpenShift CNI. We need to set up a bridge between those two for that east to west traffic. So that's one thing. Once you do that, the operator here, you install the Windows machine config operator, right? And so once you install this, you're basically ready to install a Windows node, right? And so like, how do you install a Windows node? So for that, let's do OC get machines, right? And so there's this concept of machines and machine sets in OpenShift, right? Some of that information is also making its way onto Cluster API. So if you're familiar with Cluster API, some of this terminology may be, it'll be familiar and similar. And so here I have something called a machine, right? And so
Christian, before you move along, I had a question that I kind of tried to answer in the chat, but so
sure.
How about running OpenShift locally? Like I found the Code Ready project.
Yes.
Are there any other ways to, if you want to like run this locally and test stuff?
So the best way to run locally would be CRC, Code Ready Containers. If you are like one of those K3S people, right? If you want like something really, really slimmed down, there's a project called MicroShift. So if you just Google MicroShift Red Hat, it's like the first one to hit there. That's another way to play around with OpenShift locally if you are into a lower footprint. But CRC is basically OpenShift all stuffed into a VM running on your laptop. So if you want the full experience, CRC is still the best way.
Yeah, so that would basically be the same as actually running a server and installing OpenShift and doing everything like that. Yeah.
Correct.
Perfect.
Yes.
Thank you.
Cool. Yeah. Thank you. All right. So what I was saying here, machine. The way you install a Windows node is the same way you install a Linux node, right? With a machine and a machine set. So if I do here, machine set, and so let's get WinWorker, and then this guy here. -o YAML. Oof, this is going to be hard to read. Maybe this was a bad idea, but we'll see. Okay, so so if you've ever worked with OpenShift, machine set's going to look very familiar, and this is going to look very familiar. Actually, the difference between a Windows machine set and a Linux machine set is very, very, very minute. First, you just kind of you see that label, that annotation that this is going to be a Windows operating system. This is also labeled a worker, and you basically use you tell it which image to use, and essentially that's it, right? That's really kind of the only difference. Is it's the same schema. It's just you're just providing it a different operating system there. So, and then with that, I think it's best to show that in the nodes, right? So here in the compute on OpenShift, you can see all the nodes here, all the control plane and the workers here. This one happens to be a Windows one. And it'll give you information here. It shows you that you're running Windows Server 2019, and so here you can see that it's running. You're running a Windows Server here on OpenShift. There is a taint applied to this here. Yeah, there's one taint, right? When the scheduler tries to schedule a workload, it doesn't really take into account what operating system you're using, not by default. And so, you can use node selectors. That's fine, and it'll actually error out the Linux container. Will actually try to run on the Windows node, but it'll fail. But to kind of just reduce the noise, we actually taint the node to say, hey, this is a Windows. The OS equals Windows. Make sure you don't run anything that doesn't tolerate this taint here. So that's, and then in the command line when you're doing kubectl get pods. Oh, that's my workspace. Sorry. I'll get nodes, and then this is kubernetes.io os equals Windows. You can see that is the -o wide. There we go. You see that the Windows data center running 2019, it's actually running Docker. And so for now, what we're doing is we're running Docker runtime nodes. Oops, -o wide. We're running, and and here's the Windows Server running Docker, and then the Red Hat Enterprise Linux Core OS is running Cryo. And so for now, it's running Docker. In the next release, they're actually going to switch over to Containerd. And so Windows Server, the Windows nodes are all going to be running Containerd. And the best way I've known get nodes. Let's see, get pods to log into the Windows node. There we go. Is I actually set up a Bastion SSH container, right? So everything's done via SSH. Yes, even in Windows land. SSH CMD. Let's SSH into the Windows node and the username. So here, as you can see, I'm now in a PowerShell prompt here because I'm actually logged into the Windows container. If I do a Docker PS, right, it shows that I'm running Docker version. There we go. And then it's also, see, I actually, since I'm a Linux guy, I think PS shows it. Yes, it does. Does it? Maybe it does. Maybe it doesn't. It'll show you. There we go. So here it's running the kube proxy, the kubelet, also in the hybrid overlay networking inside the Windows node. And so I don't want to exit out. Oh no, wait, maybe I do. Yes, I do.
Sure. Just while you're doing that, Christian, you mentioned obviously the deprecation of the Docker stuff and moving to Containerd in the next release. Can you tell us, or do you have an idea when the next release is due?
The next release, so it's I don't know the exact date. It will be by the end of Q3 of this year. So it'll be before the end of the year. So like sometime this year.
Okay, so for anybody using this stuff in the wild, that's when they have to, like the folks using AKS and that are having to plan already for the remover of the Docker runtime. So if you're using OpenShift, plan for that change before the end of the year.
Yeah, if you're running Windows containers, you do have to plan for that change, right? If you're just running OpenShift, we're already using Cryo, so you don't have to worry about that. But definitely, yeah, if you're using Windows containers, you do have to keep that in mind.
Awesome, thank you.
And then, so I have Windows Node is up and running. I'm running Windows Server 2019, and so let's do something fun here. I think I'm just going to drop into the other window here. Let's do also get nodes. Of course, that doesn't work. 1 second here. Okay, sort export. There we go. OC get nodes. There we go. Yeah. So then let's look at. So here, what we're going to do. Actually, let me open this up in Visual Studio Code. Make it a little easier to read. Yes, I trust myself. There we go. Web server. So what we have here, don't ask again. So here, this is a sample Windows workload, right? And so we have, again, standard thing, namespace, a service. All of this is all the same, right? You're treating your Windows containers the same way as you're treating your Linux containers. None of this is different. One thing though, a couple things that are different. One is I have to set the toleration, right? Because since the node is tainted, we need to set the toleration for all our Windows workloads. So that's something to keep in mind, right? So that's something that you do need to keep in mind if you're running this heterogeneous infrastructure here, and also the node selector, right? So so that way it lands on the right set of nodes. So that's it's really I'm running a simple PowerShell HTTP listener inside the container, running server core 2019. So this is another caveat with Windows containers, right? You can't use a Windows container from, let's say, Windows 10 on server 2019. You can't build a server 2016 container and run it in 2019. That will not work. So in the Linux world, we kind of get away with a lot. We have a lot of differences, right? I mean, I'm a Red Hat guy, obviously, but a lot of people use Debian. That's fine. Ubuntu, Alpine. Name your poison. But we're not so different, because the reason why those containers, right? If someone builds an Ubuntu container and it runs on Linux, runs on a RHEL host, is because we're fundamentally using the same kernel. Deep down, we're all the same. We're all running the same kernel, so we kind of get away with it. Someone building a container running on Ubuntu, if you're running it on OpenShift, you're actually technically running it on the Red Hat kernel, Red Hat Linux kernel, but just because we just use the same Linux kernel. And the Microsoft's a little different. So if you're using server, 2016 is a fundamentally different kernel than 2019. So you can't cheat in that aspect, right? It has to match. The OS has to match the container, kernel for kernel. We get away with it in the Linux land because we all just kind of use the same Linux kernel, but in the Windows environment, 2016, again, like I said before, different than 2019. So you just got to make sure all your containers are built to run on the node that they're going to run on the same version. So that's a big caveat. So that's something that you need to keep in mind. So, but enough of that. Let's actually run this guy. There we go. So if I do OC get pods, wind workloads, so that container's creating. The container is creating on, it should be the wind worker. Yep. So that's creating there. Let's go back to this. Here, and let's do RSH again. I forgot the name. Oh wait, no, I have it in the other window. I'm glad Robert told me this is loosey goosey, so I'm glad it's loosey goosey because I'm SSH CMD.
Is no pressure.
No pressure here.
Only doing stuff live. No pressure.
Yeah. There we go. So here, as you can see, the pause container is running, right? And so for those of you used to using Kubernetes, the pause container starts up, right, to hold that. That is still valid here. That still pertains. And now we have the Windows web server running. I believe it all runs it in one container. Oh, up arrow doesn't work. Okay. There we go. Now we have the now we have the two, now we have the pause container, and we actually have that my container running. What's really cool about this is that you can this Windows workloads. Yeah, so it's running on the Windows worker, as you saw. We did the Docker. It's running there. What's cool about this is you can do an OC. Actually, OC doesn't work for this. kubectl exec. We can actually exec into it. And we're going to exec into this guy, and I think we just PowerShell. Right. So now I'm actually in the container itself. If I run PS here, as you can see, there's no, I'm not on the host anymore. I'm in the container, so I see a smaller subset of services. One of them being that PowerShell HTTP listener that I ran in the container. So so you can even log into the container as you would like any Linux container running there. And so if I do OC get services pods in Win workloads, it also created an external IP for me. So if I go here, and you can see the Windows container server running. So usually this is where I stop the demo, but I think I wanted to do something a little more interesting, to actually just truly show that this is, that you're using Kubernetes, and the fact that you're kind of using Windows containers or Linux containers in the background should be transparent to you. But let's look at a cool example. I do have a README for cheating. Let's install something using Helm. Right. So first, I need to export some things that I don't want you guys to see because of passwords and whatnot. But let me do a Helm repo update.
Let me know if you want me to
break something
screen or something.
Okay. Oh, okay. No worries. So here I'm going to use Helm here. Let me clear the screen so you can see this. So what I have, and I say I selfishly because someone else helped me. I don't know .NET, so someone else helped me build the .NET aspect of it. But I have a Helm chart that installs an application, a multi-tiered application. So this application has a .NET Core front end with a .NET, I think 4.2, I forget what it was, backend, and a MS SQL database, right? So you can show, both of the two of those services are running on Linux. One of them is running on a Windows container, so you can see how they can interact with each other. And so again, I'm using just common tools to install my workloads. I'm using Helm to like you would in any Kubernetes cluster, to install on a workload on OpenShift, and using again, using that tool to install Windows containers as well, right? And so I'm again using common tools to manage both Windows and Linux containers here. This will look like it's stuck a little bit because one of the things that it does is actually it SSHs into the Windows container and actually pulls the image beforehand. That actually speeds up the installation a little bit. And if I go into the other window, let me exit out of here. There we go. If I do OC get pods, NCS, I think it's called. No, I think it's called a candy store. So as you can see, all those are the bootstrappers running, right? So I'm bootstrapping the database. The backend is running, right? So the backend is actually running on Windows, on the Windows containers, and the front end that's running. So we're just waiting for the database to bootstrap.
So in this case, the MS SQL is Linux.
Yes. So let's do OC get nodes, and then if I do OC get pods dash o wide, we can see where they're actually running, right? And so so the MS SQL is running. This is a Linux one. And this is the Net Candy Store. Oh, I was confused. The front end. So the front end is actually running on the Windows node, and the back end is running on Linux. So you kind of have this kind of mix and match of, your workload is running on Windows node, some of your workloads running on your Linux node, but using OpenShift, using Kubernetes, you're using a common platform, and you're essentially microservices all being managed by one platform, which I think it's actually pretty cool to have a single platform to be able to do that.
It's really good to have that kind of like option to actually run it like one place, because sometimes you have these old things that are laying around, so to speak.
Yeah.
And if you can't have that in this, strangle patterns and other types of like ways of getting rid of old code.
Yeah.
If you need to kind of split that up into several platforms, etc., so, it just gets complex really quickly. So
yeah,
if you're able to host things in one place, that I can see that it sounds beneficial, at least for me.
Especially if you have like a management platform, kind of like Kubernetes, right? It gives you this the multi-tenancy, right, aspect of Kubernetes. I think is really awesome, because we're all supposed to be about DevOps and supposed to be about working together, but you can, if you want, in regulatory things come into play, you can have your Windows team, application team, work isolated almost, right, in their own namespaces, right, and they don't necessarily know about other stuff going on in the cluster. And so
just like a by thing, because we're talking about trying to target the right nodes for the different containers that are built. Have you any experience trying to use something like Pod Affinity or something like that to try to actually hit the? I'm not sure on the Windows side, because obviously there might be a little bit difference between like what's tagged there on the node size, but doing something like that using Pod.
And that'll work. That'll definitely work. See, I'm using Node, but Pod Affinity is probably the preferred way of doing it, because I do it because it's just one, easy, and two, I only have one Windows node. But ideally, you're going to have multiple Windows nodes, right? And you might have them tiered, right? And I think that's where Pod Affinity is use something like that. And you would use, again, like I was saying before, you're kind of using to do similar things, right? There's only like a few caveats here and there, but you're using common tools for all of them.
Yeah. Thank you.
Yeah, so I think the big reveal here might be that that this might not work. Okay. Hey, you know what? I was out of all things, I didn't think the database was going to be the one having problems. So ironically, anytime I've and usually like the database is like the last thing I have to worry about. And it looks like it's still in the init phase.
Might be on Easter holiday. It's
Yeah, that's right. Yeah, so it's taking an extra few days off here.
Yeah.
It might be an Easter holiday here, because
we're going to see some live diagnostics from you here, Christian, are we?
Yeah. So if we want to dive in, what I was going to do is first what I do is I always get events, right? See if there's any like platform things that I need to worry about, but it doesn't look like it. It looks like it's all volume was successfully attached. Actually, if you want to do something cool, I always do sort by creation timestamp. I think might be meta. Here we go.
unable to attach.
Yeah. Okay.
Yeah.
Okay. So that PVC.
And now you're using the OC, but it basically is the same as using kubectl.
Yeah, it's essentially the same. It's we load the same we basically embed kubectl into OC because OC interacts with the OpenShift API for certain things like like logging in or using tokens and stuff like that makes some of those things really easy. It says it's bound, but it's having a hard time to. Timed out waiting for condition. Okay, so let's get pods.
But if the Windows pod is running.
Yeah, the Windows pod is running. Well, what's funny is MS SQL is running on the Linux node, so I'm wondering. So, like, out of all things, Linux is the one that Linux is the one that's giving us problems. Get pods, and I do maybe logs, and I might just
see what's going on.
Yeah, just for net candy store. Waiting to start. Yeah, it's waiting to start because so what I can do is OC.
You could always try and turn it off and on again.
That's exactly what I'm gonna do right now.
Yep.
It's funny. No matter how far we get.
Yeah, no matter how far we get. Yeah.
Turn it off and on again.
I'll do this, but I think I forgot to do the weight equals 0. I might do a scale down and scale back up sort of thing.
Well, in worst case scenario, the Windows pod is actually up and running, and it's running with Linux pod.
Yeah.
In the same cluster, which is
in the same. Yeah, exactly.
Yeah.
So it looks like.
And I've had issues with the MS SQL before, so. This is why I like those kind of things as a service.
Yeah. Just shift those stateful workloads outside of your Kubernetes.
Make Microsoft deal with it.
To be fair, I probably made enemies with that statement, but yeah, I'm very much like you, Robert. I do prefer those stateful data transaction-y type services outside of Kubernetes. So.
There's nothing really wrong with state in Kubernetes, and so like having stateful things. It's just it automatically gets harder to deal with. It's really nice to be able to say, hey, I need a database, I need an instance on a SQL server, and then Microsoft just says, all right, cool, here you have it. You need to scale it up. All right, cool, let's do that as well. But there might be, and it's usually because of stuff like volumes, persistent volume claims and things like that.
So like you guys having the conversation about things like databases in a stateful in Kubernetes, right? I actually also prefer to have those things outside that cluster, specifically databases, right? So layer, right? Like you might be running Redis, or you might be running I don't know, maybe local copies for development purposes, but for like production workloads, haven't seen a lot of people running them inside of Kubernetes.
It's perfectly fine if you have like the way that I see it, if you have several dev environments, for instance, it's cool if you just like pull up a database of some sort into a container and then just use that. But then obviously that's going to get nuked when you're done.
Yeah.
But for production things like this happen.
Yeah.
Things like this happens all the time, and it's really hard to figure out why. And if you don't use any kind of like storage solutions and things like that to kind of abstract away all the pain, all of a sudden it gets really hard to figure out what's going on. So
Yeah.
this is perfectly, this is a good example of that.
I wonder if, I don't know how much time we got, but I wonder if I do this.
Well, we're at time right now, but
yeah.
there's no questions popping out at the moment, so
Yeah.
so it's perfectly fine. Like I said, we got the idea, and obviously there's some caveats, like you said. Things like if you are you probably should standardize on some sort of like Windows version, because or else you will have to have different node, pools with different versions of Windows, and then also Linux nodes. So it gets hard, but it's possible. And obviously the what do you think, Christian? Like where we're at now with Windows containers, because it used to be really bad. It's like it used to be really, really bad, but piece by piece, they're making improvements.
Yeah.
It's going forward. It's not completely like feature parity or something like that, but it's at least like usable now compared to what it used to be. What do you think about that?
I definitely do think it's really usable. As you said, those engineers has done a lot of work, and then with Red Hat joining those same Microsoft engineers, accelerating some of the feature parity. You're right, the feature parity isn't there, but that's essentially the ultimate goal, right? Is essentially have the same features that you have with Linux containers to have them also with the Windows containers. We do have customers running Windows containers in production. Unfortunately, I can't say who, right? Because I can't say who, but we do have them running in production. So
and I was about to say we have a customer who has hundreds and had hundreds of web apps running in Azure, presenting services and web services to their customers, and we have literally migrated hundreds of those web apps and app services into Windows containers running on AKS. So there are plenty of production use cases for this, and it perhaps for those, like you said earlier, but those traditional or not traditional, the .NET and the Windows-based developers and Windows-based apps and stuff, it eases the transition into a more cloud-native way of working. So they want to get off their expensive app services. They want to get into Kubernetes. So get into Kubernetes on your Windows containers, and then look at refactoring and re-architecting your app so that the next iteration is Linux containers. So there are definitely production workloads out there, and we have a specific customer I'm thinking of is running hundreds of containers, hundreds of customers on Kubernetes clusters using Windows containers.
Yeah, and which I find kind of the main use case that I've seen is the legacy .NET applications, right? But there's also applications like C#, right, that we've seen bubble up with maybe not a lot of people, but they're customers and clients always have weird use cases, but it's really cool because it's like, oh, we never thought about supporting that. Let's try to help them out. So there's also applications coming like from the C# aspect, right? From running, let's say someone's running manufacturing, right? And they have some code in running C# on Windows. Those are also eligible, right, to be running on Windows containers as well. So
there's obviously like the room for a certain like OS specific APIs that people need to use for certain things that they at some point you can't get away from. We need a Windows box or a Linux box that kind of goes both ways in that sense, and just having the option is the main thing. Like we want it to be flexible. We don't want to say you need to do it in a certain way, and if you are thinking outside of that box, then some bad words. I'm back I'm already starting to swear. I'm not going to swear. Try not to.
Yeah. So unless there's any questions in the chat, if there are, feel free to ask them, and we'll pose them to Christian before we wrap up here in a couple of minutes. But one thing I wanted to ask you, Christian. So we're Azure advocates. So
Mhm.
I wanted to put you on the spot and ask you,
Sure.
OpenShift versus AKS. Why would we pick one over the other? Why would we pick OpenShift over
Yeah.
AKS, perhaps?
Yeah, to talk about putting in the hot seat, right? I'm gonna talk. I'm gonna. You're gonna. I'm gonna try to sell. So so OpenShift to a bunch of AKS users. So if you need to own the entire stack yourself, right? So the you need to own, if you need to own the OS, right? If you need to own the entire stack, not only from like the applications, but also from like the operating system up. OpenShift is the way to use it, the way to go, right? And also because you have that consistent experience across multiple clouds, right? And so it's if you're gonna use AKS, and then maybe you're going to use EKS or maybe GKE, and then maybe
There are differences. Yeah.
yeah. There's like differences here and there, and if then you could just install OpenShift, and like that experience is consistent across multiple
And when you're
clouds.
saying install OpenShift, are you talking about the ARO OpenShift, or so that's the Azure and Red Hat managed OpenShift, isn't it? Or just OpenShift proper? Is there a
Oh
difference?
yeah. So the difference between the two is one is a managed service, right?
Yeah.
So ARO is a managed service, meaning that it acts almost like AKS, where you're kind of just consuming the OpenShift resources there.
Yeah.
And that's kind of it's analogous to there's one for the other hyperscalers. I think the ROSA is the one for Amazon, right? And that one is kind of like the same kind of ideas where like I don't want to manage it, let someone else manage it, but I want to consume it. Those are more analogous. I was talking more specifically about the I guess, for lack of a better term, OpenShift proper, where you actually install it on.
Yeah, roll your own OpenShift on. Yep.
Yeah, exactly.
The way that I see it, there's plenty of things in OpenShift itself that's kind of like a reason to use OpenShift, and like the reason why I do like and prefer to do AKS when I'm doing Kubernetes stuff is just because I don't want to deal with like upgrading things. I don't want to deal with all of those kind of things. I want to have that all taken away so I can just get a Kubernetes, ready to go.
Yeah.
It just give me a Kubernetes API, and I can put stuff in it, and I can run pods, and that's cool. So having that kind of experience just with OpenShift as well, is very appealing to me. And I know, for instance, there's a lot of OpenShift customers, in Norway, like governmentals that have like their own data center and stuff like that. And having that kind of like public cloud offering that would give them the same type of experience, so they can start like bursting into cloud in the same fashion that they do on premises. That's just perfect for those kind of customers as well. So I think that's a really great offering.
Yeah. So there's my political, I guess, answer to what you.
Yeah,
it's all good. It was useful to ask the question, because I'm sure there are people have been watching or are using AKS and going, well, why would I use OpenShift? And no, that was a great answer. So thank you for that.
Yep. And obviously, if you're doing AKS, what you're getting is Kubernetes, and then you have to install stuff. Then you have to like get all the tools up and running, and and obviously I know what I want. So when I'm doing AKS, I know what I'm putting in. I know all the tools that I'm using. But if you don't, or if you just want like Kubernetes in a box, but with tools and kind of like an opinion, like I said, it's an opinionated Kubernetes platform. There's stuff there that you can just start using, and I think that's kind of why you want to go for something like OpenShift in the end, in many cases at least.
We call it batteries included, right? So like batteries included sort of toy, right? I made the analogy of Legos versus buying the toy. You also get the batteries with the toy as well, right? And that's kind of like the whole idea of this is why we call it OpenShift Container Platform, and not something like OKS or whatever. Like we do use Kubernetes, and it's essentially Kubernetes as like but like it's a whole platform, right? Like it's like all the tools, all the services, all the things you need in order to run it in in a production case, right? Like on-prem.
But in this case, Kubernetes is basically just a platform you're creating the platform on.
Yes,
like it's
correct. Yeah, it's a platform that we're using to create the overarching platform.
Yeah. All right. Well, we're over time, so I think we'll have to stop now. But it's great having you on here, Christian. It was a really good introduction to both OpenShift and obviously then Windows containers, coexisting with Linux containers. 2022, the year of actually doing whatever you want.
Awesome.
No one should bash you for using one or over the other.
No,
exactly.
It's
awesome.
Perfect.
I appreciate it. Thank you.
Always been anti-fanboy. I sit on a Mac. I use Linux servers. I sit on Windows machines. I don't care.
You don't. Whatever gets the job done, right? This is what it is.
you shouldn't care. It's perfectly fine. And now we got good alternatives for that on container side as well with Windows containers. So thank you, Christian, and thanks everyone for watching. Have a great one.
See ya.
Cheers.